How to make a good tank even better. Take an old T-72, increase target accuracy, upgrade the protection, maneuverability, and you will see how a regular armored vehicle becomes a beast, striking an axe into the enemy. Siberians like open spaces, open minds, and open hearts. The city of Omsk may serve as the best metaphor for all of these. It's a big river port, for it stands on the banks of the Irtysh River. As any Siberian city, it's famous for its severe climate, so this is maybe the best place in the world to build tanks. These machines should be simple in construction and powerful on a battlefield, and it seems that when it's so cold, you just can't make a bad tank. This factory was founded in 1896. They needed a facility to repair locomotives for the Trans-Siberian Railway. During World War II, Leningrad Voroshilov tank plant was moved here, and the factory started to produce tanks. We came here on purpose to see a renewed T-72 heavy tank. The plant was named Omsk Transmash. It has produced the legendary T-34, T-55, and T-80. Now it supplies military engineering transport and bridge laying machines. They also repair and upgrade combat vehicles here. The product range seems to be unlimited. The factory is huge. It occupies nearly 2.5 million square meters. This is a real military industry giant. The T-72 was born in the late 1960s. At first, it was planned to change the old power engine of the T-64A to a new one, which would be cheaper and more reliable. But Russian engineers never stopped. They changed almost everything, including the loading mechanism and the running gear. The machine was named the T-72, and they have made as many as 30,000 of them. Nevertheless, even legendary tanks need upgrading. New wars, new rules. Repairs are not enough. Modern equipment needs to be installed anyway. The T-72's upgrade process is gradual. Only after the machines have undergone several production stages, it is ready to meet the modern world, full of new threats. It gets a more effective gun, a better protection shield, a new firing targeting system, and other things which it might need to survive a battle. Anatoly, hello. This is the first overhaul stage. Here, we dismantle tanks. First, the vehicles are washed and checked for gun shells and other explosives left inside. We take off the turrets from the gear parts. Then, we work on them separately. Some parts are disposed and some recycled. We change them for new ones. Other modules are subjected to an upgrade. They start with dismantling the machine and washing all the parts. Almost 20,000 pieces need to be taken off and numbered. Some of them have to be disposed of. The others need some repair. Siberian plant workers will make the tank 30 years younger. They start with the installation of explosive reactive armor. Anatoly, I can smell welding. What are they doing here? Alexei, we are at the welding assembly line. Here we work on a new tank shell for the T-72B3. Here, the explosive reactive armor is being installed. Vyacheslav can explain it a lot better. Vyacheslav, hello. So, there is the shell of a T-72 tank, and it is ready for upgrades, right? Yes. This is the ERA, which stands for Explosive Reactive Armor. If the shell is under gunfire of bullets or even 30mm shells, it doesn't explode. It's designed to withstand a hit of anti-tank weapons. As a result, a T-72B3 survives the hit of armor-piercing projectiles twice as better as the old model. And it's 50% more effective when it comes to a hardcore shell hit. I hope welders won't get jealous. I think they won't. Whoops. I'm definitely doing something, but I doubt that I am doing it right. It doesn't look like a proper piece of work. So, Vyacheslav, look here. What do you think? You know, it looks like you cannot find a proper word, right? Never mind. Our welders will fix it. They're the best. Okay, let me finish this first so they will have something to fix. Plates and fins of the ERA are made of strong metals, so the armor gets stronger even without the explosive element. It makes the vehicle 1 ton heavier. After the shell plates are welded together and all the armor elements are installed, what is going to happen next? The shell is going to take a bath, as we call it. This is how we check it for probable leaks. Okay, so it's better to give the welding machine to someone who could use it more effectively. I hope you will fix everything I've done, and I will have a look at the shell taking a bath. A crane takes a shell into a basin filled with anti-rust compound. It is left there for 20 minutes while the staff is performing a leak test. If necessary, they will fix the leaks manually and repeat the procedure. Cool, so it's as simple as that, right? Okay, I got it. Now, as they took the shell to the reservoir, it's time to sink it into the compound. 2.5 meters below the surface. It's frightening a bit, but now I have to go inside and check the hull for leakage. If the joints turn out loose, they have to be re-welded. Even though I hammered it hard enough, I didn't find anything. The shell will be thoroughly examined one more time. Then they install new torsion bars, gearboxes, and tracks. And now let's have a look at the most important mechanical part of the tank. It's a brand new, powerful engine. So this is the new engine for the T-72B3. What was wrong with the old one? Why is this thing better than its predecessor? Well, this engine has a new design. It's called the V84. And it was designed especially for the T-72B3. First, it allows the vehicle to go faster. Second, a more powerful engine can carry a bigger weight. It means we are able to install more protection and equipment. Throughout all its history, the T-72 has changed a number of V-type engines. The first one was called the V2. They installed the same power package to the legendary T-34. This V84 is turbocharged. It provides 840 brake horsepower. Usually, the more powerful engine we have, the more heat it produces. It makes the tank more visible in thermal viewers. Is it a problem? The designers thought about it. Such a big engine will enlarge the tank's heat signature. They have managed to solve this problem with the use of aluminum gill-finned radiators. The engine is delivered to the factory without any auxiliary equipment. It is installed here. They set up an exhaust smoke system, injectors, and clutches. Then the cooling system and oil inputs are connected. The engine is ready to be set in the tank, but it still needs some adjustments. We have seen how they make it. Now it's time for the ride. I'm trying to walk as fast as I can and I'm shaking all over. But the reason is not that I'm excited that much, though I am, it's just bitterly cold.